go. We begin with Charles Ugwu from the College of Veterinary Medicine.
What happens if a human being decides to stop eating for an extended period? Well, that person is eventually going to die. So please, make sure to eat well always. Why? Because as living organisms, including humans, livestock, pets, and guess what? Even bacteria that cause disease, we all depend on food to survive. Now, imagine for a moment that a certain harmful bacteria have just entered my body. But it turns out both the bacteria and I depend on the same food to survive. Let's say sandwiches. And by the way, I love sandwiches. But you see, I need my 2 hands to eat a sandwich. But the bacteria doesn't even have hands. So what if I could discover the alternative tool the bacteria intends to use to access my sandwich, which is unique to the bacteria and not even important to me as the host? That is where my research comes in, because with that information, pharmaceutical companies will design drugs to target and destroy that alternative tool, cutting off the bacteria's access to my sandwich, starving the bacteria to death, while I can still go ahead with my beautiful hands to enjoy my sandwich. Take, for example, Coxella bonnetti, a harmful bacteria whose infection during pregnancy results in abortion 50% of the time, and death of the unborn baby 25% of the time, in both humans and livestock. Interestingly, when this bacteria infects the host, it needs glucose to survive. But we also need glucose to survive. So as a therapeutic strategy, we can't just take away glucose from the human body. Otherwise, you kill both the bacteria and the host. And you don't want that. So here's the catch. Humans use hexokinase, a biological tool, to process glucose. Coxella does not. My research seeks to discover the alternative tool Coxella uses. And if it turns out, as we hypothesize, to be something unique to Coxella and not even important to us as the host, we can target that to stop Coxella from utilizing glucose, from surviving, and essentially disarm the bacteria from being able to cause disease. Effectively, we stop the bacteria and we save the host. We believe this approach, which is simple, innovative, but yet very powerful and potent, can be leveraged to control Coxella and other deadly bacteria, especially at a time with rising antibiotic resistance. Because whether you're in science, art, business, education, entertainment, or even politics, we can all agree from the COVID-19 pandemic example that in today's interconnected world, an outbreak of infectious disease anywhere in the world is a threat to public health everywhere in the world. Thank you.